For question number 6 on page 420, we are taking the region bounded by y is equal to ln x. X is 0, so in other words, the y-axis. Y is equal to 1 and y is equal to 2. And according to the problem, we're taking this and we're rotating this over the y-axis. So when we spin this over the y-axis, we're going to get something that looks kind of like that sort of shape. And I'm going to slice this in order to get shapes that are sort of similar. What I'm going to do is slice this perpendicular to the x-axis. So I'm going to get disks that look like this. And again, they're not really disks, but what I do know is that the thickness of each disk is a little movement, little bitty movement in the vertical direction, so that is dy. And I'm still going to use pi times the radius squared times the thickness, but my radius now goes from the y-axis all the way out to the edge. And that, anytime I make a horizontal movement like that, that is a big change in x. So I need my x here minus my x here. My x here as a function of y is x in here. X is really e to the y. So I have e to the y minus 0. So my total volume is going to be the sum of all of those disks. I'm going to have pi, my radius squared times the thickness, and my limits of integration, y is going from 1 to 2. So in other words, our volume is going to be pi 1 to 2 e to the 2y dy. This would be a situation where we would use substitution. So I would let u be equal to 2y. du is 2 dy. We don't need 2 dy, so 1/2 du equals dy. So then this is going to become, our volume is going to be pi. In fact, I'm going to change my limits of integration. If u is 2y, so this is going to give us 1/2 e to the u du, and now I'm integrating with regard to u, so I'll change my limits of integration to u values. So u goes from 2 to 4, so our volume is just pi over 2. We're going to have e to the u between 2 and 4, so our volume is pi over 2 e to the 4th minus e squared, and that's all you can do.